turn to the science of mechanics. This science deals with the action of forces on bodies. The forces we're interested in are those that act upon the pilot and paraglider. Let's start with a simplified model of the low and high pressure zones, lift. This force acts upon a point known as the center of pressure. This point is merely an average of the lift forces acting upon the paraglider. When traveling through the air, the paraglider encounters resistance and creates turbulence in its wake. The force that opposes its forward movement is known as drag. Since these are the two main forces that act upon the profile, we can add them. Their sum gives us the resultant. How do we obtain the relative airflow necessary to create lift when there isn't any wind? By simply transferring his weight to the wing, the pilot pulls it towards the ground, forcing it to move forward through the air. This movement we call airspeed, and this creates the relative airflow required to produce lift. Altitude, therefore, is the paraglider's energy reserve, and by using our weight to draw on this reserve, we're able to fly. As mentioned before, the angle of attack is the angle at which the relative wind meets the profile. This angle should not be confused with the angle to the horizon, known as attitude, as it's possible to have a relatively high angle of attack with the wing at any attitude. In normal flight, the paraglider remains at a constant angle of attack and at a constant airspeed. The pilot can influence the angle of attack and thus the speed by using the brakes or speed system. The angle of attack and airspeed are very much related. If you change the angle of attack, the airspeed too will change until a new equilibrium is achieved. The angle of attack can be increased by applying the brakes evenly. This causes a corresponding decrease in airspeed. The greater the angle of attack, the more lift is produced. However, more drag is also produced. If too much brake is applied, then the smooth airflow over the profile cannot be maintained, and the airflow breaks away from the top surface. This is known as a stall. Being aware of the stall is very important when learning to fly, since inadvertent stalls are very dangerous and should be avoided. Always keep your hands high and make sure you feel good airspeed on your face whilst flying to avoid the stall. Only when making the landing flare should you use deep brake inputs. The angle of attack can be decreased using the accelerator system. As the angle decreases, drag is reduced and the speed increases. The glider continues to accelerate until a new equilibrium is found. The wing then stabilizes at this new speed and sink rate. At low angles of attack, paragliders are more prone to collapse. This is why you should not use the speed system when close to the ground or flying in turbulent air. Let's turn to the concepts of lift to drag and glide ratios. The lift to drag ratio is the angle at which the paraglider glides. These concepts will help you understand why this student barely manages to lift off from this slope. They are simply ratios that measure the glide capability of your wing. These ratios are obtained by dividing the horizontal distance covered by the vertical distance lost. In this example, 750 meters divided by 100 meters gives us a ratio of 7.5. As you may have guessed, the greater the horizontal distance is, the greater this ratio will be, and the longer you'll glide. This is called your lift-to-drag ratio. It's a technical specification of your wing. The lift-to-drag ratio doesn't change unless the wing is damaged. We'll see later on in the flight chapter that the wind or micrometeorology can influence the trajectory. The distance covered will vary, and in this case we'd refer to its glide ratio. Let's go back to the example with our student. He can't lift off because his lift-to-drag ratio is too close to the angle of this slope. For launches, we'll need a hill whose slope is steeper than the lift-to-drag ratio of our wings. Modern paragliders have a lift-to-drag ratio between 6 and 10 to 1. For reference, you can compare this with a lift-to-drag ratio of 15 to 1 for hang gliders and almost 60 to 1 for sailplanes. Paragliders have a large speed range, and knowing when to use these different speeds is very important. You have control of the speed with the brakes and the speed bar. This is known as speed to fly. Knowing to fly at the right speed, depending on conditions or the site, is the basis of safe and efficient piloting. Understanding different flying speeds will make you a better pilot. The correct speed and just the right timing makes it possible for this student to make a smooth landing. As a general rule, when in lift, slow down, and when in sink or headwind, speed up. This increases your efficiency and prolongs your glide performance. Flying at trim speed, your glider will achieve its best glide angle in calm air. The pilot's arms are high, with no pressure on the brake handles. At this speed, the profile isn't warped in any way and therefore creates the least amount of drag. Flying like this will allow you to cover the maximum distance. Most modern paragliders have a trim speed of around 36 or 37 kilometers per hour. When learning, the main reason for flying at such a speed is to accelerate before landing and build up energy that will eventually be converted into a flare. This makes a soft landing possible. Flying at trim speed also reduces the likelihood of problems caused by the wind gradient, such as inadvertent stalls or sudden altitude loss near the ground. Apply the brakes approximately 30 to 40 centimeters to reach the minimum sink rate. The pilot's arms are about level with his shoulders or just below, and there is a positive pressure through the brake handles. Applying pressure to the brake handles will also improve your sensitivity to the wing's movements and increases the internal pressure and angle of attack of the wing, which reduces the likelihood of collapses. Flying at min-sync increases the angle of attack and significantly increases drag, which reduces the ability to glide and consequently reduces the distance that can be covered. However, flying like this gives you the slowest vertical speed. In other words, you sink at the slowest rate. You can take advantage of this when flying in lifting air. Note also that other than the landing flare, it is never necessary to fly slower than the minimum sink rate.